So just like with real numbers, matrices have operations that we can do. We can add and subtract matrices, which you already know how to do. We can multiply them. Division is a little weird. Instead of dividing, what we do is multiply by the inverse, and we'll get to that. But just like if we have 4 plus x, I can add negative 4 to that, right? And I can add negative 4 to both sides, right? And that would help me solve for x. These would go away. And then x would equal 11, right? 15 minus 4, 15 plus negative 4. You want to think more, instead of subtraction, with matrices, I like to think of more of the negative of it, adding the negative instead of subtracting. And if I have multiplication, so this is the one thing that's very different about matrices. So with real numbers, you know that I can multiply this by 1/3, right? We're not going to divide. So 3 times 1/3, right? The inverse, right? Isn't this the inverse? Remember, we've already learned about what an inverse is. We can multiply by the inverse, and we can multiply over here by the inverse. But notice as I did this, I put the 1/3 in front over here, and here I put it in the back. So the thing about matrices is that if we have 3x equals 10, I'm going to leave a little space, and we're going to multiply by the inverse. The one big difference with multiplication of matrices is that order matters. So if you multiply, you want to think about multiplying to the front or to the left or multiplying to the right. So if I take this and I multiply 3 by 1/3, then I have to come over here and multiply the 1/3 in front of that 10. I can't do it behind because order is important. So if you think of these, I want you to think of these right now as like a matrix. So if I have a matrix that is, I'm just going to call it 3, like what if I said matrix A? I can multiply it by its inverse, right? Isn't this just the inverse, right? This is the inverse. Or A to the -1 if we call this matrix A. Okay? So here I have a system of equations, right? I have 3 equations and 3 variables. So you already know that you can solve this using RRF, right? If you can put this in your calculator, RRF, you would enter this as a 3 by 4. And you also know how to do this by hand using row echelon. But row echelon, I think, is a little tedious and a little long, so I'm going to show you using inverses how we can solve this. So the first thing we need to learn is how to just write this as a matrix, because it doesn't look like a matrix to me right now. So what we have is we're going to break it into 3 parts. We're going to break it into the coefficient matrix. So that is the matrix, just the coefficients. So 1, -1, 1, 0, 2, -1. See where the 0 came from? And 2, 3, 0. So that is the coefficients of all of my variables. Then most textbooks call this the X, it's a big capital X matrix, and this is just X1, X2, and X3. Okay, so in most textbooks you're going to see this as like a big capital X. Okay, and then we put another matrix, what our values equal. So 3, 1, and 4. Okay, so that's just how to write it. That's just how to convert it from this big mess right here to nice matrices, because we can work with those now. And make sure you can go backwards too. So I know on your homework there's an assignment where it gives it to you like this, and it just asks you to write this out, and then you need to be able to take this and write it as this. So basically, if you can see, what you're doing is you're taking this first, if we take this first row and we multiply by this first column, don't I get just x to the 1, which is right here, minus x to the 2, which is right here, plus x to the 3rd, which is right here, and that would equal this first position. As we do, don't forget how to multiply. First row times first column equals this number. So see how this first row and this first column equals that number. So make sure you can go both ways. So this is just the previous problem from before. I just rewrote it, and we're going to use what we know about inverses and identity matrix to help solve this. So remember, this is just an alternative method. You can still use reduced row echelon, the Gauss-Jordan stuff. If you have to do it by hand, you can do it on the calculator using RRF, but this is just another way to solve this equation. So if I have a matrix, I certainly can find its inverse. Just like if I had the number, 3x equals 15, and I wanted to solve for x, I can multiply this by its inverse, right? The inverse of 3 is 1/3, and I would multiply this side by 1/3. So remember, with matrices, the big rule you always need to remember is that multiplication is not commutative. So I could not put I could not multiply by 1/3 on the back side. It has to be, if I multiply in front here, I have to multiply in front here. Okay, and likewise, it works the other way. If you multiply in back, you can multiply in back. So it just make sure that you know that multiplication is not commutative. All right, so if I can find the inverse of this guy, and you do not need to know how to find the inverse by hand. So the inverse of this is, so I'm going to multiply this by the inverse. Then if I multiply over here by the inverse, what happens? If I multiply this side, this matrix, by its inverse, what do I get out? Well, that's just the identity matrix, right? So if I can figure out what this inverse is and multiply, this side is just going to be the identity matrix. So it would look like this. 0, 1, 0, and 0, 0, 1, and it would be multiplied by x1, x2, and x3. Well, remember, this is just another way of thinking of the number 1, and 1 times anything is itself. So basically, this side goes away, right? Because 1 is nothing with multiplication. So all I have to do, the only operation I'm left to do, is figure out what the inverse was and multiply it by this matrix. So, and again, you do not need to know how to do the inverse on the by hand, but you do need to know how to do it on the calculator. And the way that we do it on the calculator is we type this, we type this matrix into our calculator right here. So we type that in, and then we use the inverse key. So if, let's say I call this A in my calculator, then I would do A, and your inverse key is looks like x to the -1, and it's on the left side of your calculator. So you would do just that little -1, and then your calculator will spit out the inverse. So that's how to do it on the calculator. See me if you don't know how to do it. So the inverse of this is 3, 3, -1, -2, -2, 1, and -4, -5, 2. So that's the inverse, and I'm simply going to multiply it by this matrix. This is just, and if you want to enter this matrix right here as a, or into your calculator, you certainly can. It's just a 3×1 matrix, and then you're just simply going to multiply them. So it equals, you're going to get a 3×1 answer, and it's 8, -4, -9. And we generally write our answers like x1 equals 8, x2 equals -4, and x3 equals -9. And that would be your answer.